We briefly mentioned the windowing clause in a previous lesson, but let's look more into it in this lesson. Windows defines the start and the end rows within each group. It determines which rows will actually be included in your computation or in your analysis. So in other words, it acts as a filter or a where clause within the analytic function. As we mentioned before, whenever we use the order by clause within an analytic function, we are indirectly defining a window which includes the current row plus all preceding rows, or as it is technically called, the range unbounded preceding window. When the partition by clause is used, it slices the data into groups and applies the analytic function in each group independently. When a windowing clause is added to that partition clause, then it further sub-partitions each partition by selecting the specific rows as candidate rows on which the analytic function will be applied. In fact, the windowing clause is like an extension to the order by clause, so it must always be used together with the order by clause. This is an example of a statement that uses a windowing clause. The first part of this clause is not strange to us. It's the same like we've been writing before. It selects the employee salary and the ID, the sum of salaries partitioned by department ID, ordered by the employee ID, but this time we are specifying rows 1 preceding, which is the window. This means that within each department, we are not computing the total salaries for the current row and all preceding rows, but this time we are summing the salaries of the current row and one preceding row, which is defined by rows 1 preceding in our clause. So if you look at the results of this query, it's pretty straightforward. The employee ID 100, who is king and belongs to department 90, has a salary of 24,000. So the running total at that point is 24,000. When you go to the next employee, who is Kokha and belongs to the same department, his salary is 17,000. So the sum or the running total at that point is 41,000 because it's 17 plus 24. And because we are summing the current row and one preceding row, we are summing the first and the previous salaries. But if you go to Dehan, who is the third employee on the list and belongs to that same department, then you see that his running total is the sum of his salary and the salary of the person immediately preceding him, excluding his second follower. So the result or the cumulative total for this third employee is 34,000, which is 17,000 plus 17,000. So you can begin to see the difference, how the rows 1 preceding window can narrow down your data so that the analytic function is only applied to that particular chunk of data. The windowing clause has two forms. The first form is rows, which indicates the specific number of rows on which the analytic function will be applied relative to the current row. That is, the number of rows to be included in the computation. This is what we did in the previous example, where we said it should only take the current row and one preceding row. So we are specifying the number of rows that should be included within that computation. And you see here, again, it doesn't nullify the power of partition by and order by clauses. Why? Because if you look at what's going on here, it continues to reset the running total once you change the department. In fact, you can take this even further. Here we are taking one direction. We are saying the current row and one row preceding that current row. But you can take this a step further to include the current row, any number of rows before it, and any number of rows after it. In this case, we are saying rows between one preceding and one following, which means for each employee, it's going to take a sum of that employee's salary plus the salary of the person who is directly before him and the salary of the person who is directly after him. So if you look at Dehan here, his sum is 43, which is a total of 17 plus 17 plus 9, and that gives 43. That is the row type window function. The second form of window is the range window, which I honestly find sometimes more useful than specifying the number of rows. With the range window, you specify a range of values in a specific column relative to the value of the current row. Consider this statement. It says Select the last name, department ID, hire date, salary, average of salary. This time we are not using sum. This is the average of salary over department ID, order by hire date, range 365 preceding as 1 year average. This query returns the average of salaries for each employee ordered by their hire date, but in this case we specify a range window of 365 days, which is 1 year. So we are literally telling Oracle, give me the average salary of each employee and all employees who were hired 1 year before them. So the average is only computed for the current role and the people whose hire date falls within 365 days of the current employee's hire date. Of course, you could also modify this to include 365 days preceding, 365 days following, or whatever number of days preceding, whatever number of days following, which means give me the average of salaries of this employee, including all those who were hired 365 days or 1 year before him and those who were hired 1 year after him. That is the window within which you want to calculate your average. In fact, there are various ways in which you could specify this range. You could specify the range using the keyword interval as well. So in this case, I'm returning exactly the same results except I'm using an interval keyword, which says range between the interval of 1 year preceding and interval 1 year following. And that is the window over which I want to see my average salaries. In this case, this is a moving average. Let's turn over to SQL Developer and see exactly how this works. Here in SQL Developer, I've indicated a couple of scenarios that we're going to use to better understand how these windows work in an analytic function. Let me just recap a little bit to an example that did not use a windowing function here. And it's just calculating the running totals within each department. So we partition by department, and within each department, we are returning the running totals. And as we mentioned, by default, it's taking the current row and all preceding rows in each department. But in the next case, we have a query that uses a window. And the window here is rows 1 preceding. So it wants to calculate the sum, not of all rows preceding, but just one row preceding. So if you run that, for each employee within each department, it tells us the employee salary as well as the sum of that employee salary and the person just before him, which returns a running total with a moving window. Again, we mentioned that the direction can be preceding or following. So preceding means the rows before, following means the rows after. So in this case, we are just saying, give me the sum of salaries for that employee and one employee who is directly behind him and the employee who is directly in front of him. If I run that, it gives us separate results again, which is exactly what we saw in our slideshow. So for the employee Austin, for instance, his running total would be the sum of the salary of the person who is directly behind him, who is Ernst, and his salary, and the person who is directly in front of him. And that sum gives us 15,600. The next example demonstrates the range window. So the previous one was the rows window, and the next one is the range window, which specifies the range of values within which you want to execute your function. And here we are saying, give me the average salary, partition it by department ID, ordered by the hire date, but this time only give me the average that includes the current person's salary and the salary of anyone who was hired 1 year before them. So if I run this statement, you'd see that it returns the average in a 1 year preceding window. Now let's look at an example here. Let's look at the first person, who is Wallen. Now Wallen was hired on 17 September 2003. His salary is 4,400. And so the average for that department is 4,400 because he's the only one in the department and there's no one who was hired before him. Also, when you go to the next department, Faye, who was hired on 17th August 2005, his salary is 6,000, but his moving average is also 6,000. That is because there's nobody who was hired 1 year before Faye. So if there's anybody who was hired anytime within the window of 17th August 2005 and 17th August 2004, then that person would fall inside this window. But there's no one in that department who was hired during that 1 year window. Now let's look at a case here like Bell. Bell was hired on the 4th of February 2004 and his salary is $4,000. Moving average is $4,640. Why is that? It's because the average is calculated based on Bell's salary as well as all salaries of employees who were hired within 1 year window before Bell was hired. So anybody whose hire date falls within 04 February 2004 and 04 February 2003 would be included in the calculation of Bell's average. And that would include everybody within this range, right down to Bell's average, which would give us the average of 6,440. If there was anyone who was not hired within this period, their salary would not be included in the calculation of this average. Of course, we could specify preceding and following. So if I run the preceding and following, it means the average would include the current employee salary as well as all those who were hired 365 days before him and those who were hired 365 days after him, which would be a 2-year window centered on the current role. Of course, as we mentioned, if you're not prepared to specify this range as days between and days after, you can always change this to interval 1 year preceding, interval 1 year following, and you see the results of interval 1 year preceding and 1 year following are the same as the results of between 365 preceding, 365 following. And if you did not want to specify years, you could actually say interval 1 month preceding, 1 year following. So you can mix and match these different specifications as you like.